So based on this, we'll solve some problems. So here, this is the problem. There is a pumping well, and the aquifer is a confined aquifer. You can see here, this is bedrock, and this is confining aquifer. So the thickness of the aquifer is B. It is not given, but it is B. Okay. Now, sorry, B is given. B is 40 meters. B is given as 40 meters. Then discharge is given as 400 meter cube per hour. And this is the pumping well. Okay, this is the pumping well. Now there are two observation wells. One observation well is at a distance of R1, which is equal to 25 meters. And another observation well is at R2, which is 75 meters from the pumping well. And the corresponding heads are given, H1 and H2 are given as 85.3 meters and 89.6 meters. You are supposed to calculate the transmittivity. So, T. What is the equation? This is the equation. H2 is equal to H1. Following our notation, so this is our equation. This is our equation. It is S1 minus S2. Now what is S1? This is S1. And this is S2. So S2 minus S1 or S1 minus. Now if you take this, this is H0. I'm sorry. This is S. This is S1, S2. And this is S1. So if you take this as H0, what is the relationship between H and S? H0 is equal to H2 plus S2. which is also equal to H1 plus S1. So if you want to write H1 minus S1 minus S2 here, S1 minus S2 is equal to so this minus this. These two are equal. So you bring this S2 here, take this there. So it is H2 minus H1. So if you write here, rewrite this equation, take this S1 minus S2 this side. So S1 minus S2, which is equal to H2 minus H1, is equal to Q divided by 2 pi t Actually, we can leave it like this only. Anyhow, 2 pi t. I just wanted to show this equation which we have considered and this equation are one and the same. So q by 2 pi t into log R2 by R1. Or H2 is equal to, from this I can write from this equation I can write H2 is equal to this H1 can be taken this side. So it will be H1 plus Q divided by 2 pi t into log R2 by R1. So this is this equation is same as this equation. So therefore, what we can directly take is that S1 minus S2 is equal to H2 minus H1. So from this, I will automatically get this. because S1 minus S2 is simply H2 minus H1. So this can be replaced by this. So this is the equation. So here you are supposed to calculate the transmissivity. So in this equation, this is not known. Q is, T is question mark. Q is given. H2 is given. H1 is given. R2 is given. R1 is given. So substitute everything, you will get T. Is this clear to you? All of you? Yeah.
Yes, sir.
Now, I am adding one more to find K.
Sir, H1, H2, two pipes here.
What is K? How do you get K?
Sir,
Huh? Oh, 1 minute.
KB?
Sorry. 1 minute. Yes.
sir, H1, H2, what are those pipes, sir?
See, you want to know what is H1 and H2, isn't it?
Yes, sir, it is a decrease in water table or pipes, sir.
Are you seeing the figure here?
Yes, sir.
So this is H1, right?
Yes, sir, it is impervious, no, sir?
This is H2. This is a confined aquifer.
Yes, sir.
So this is a confining bed at the top, and this is a confining bed at the bottom. And this is your pumping well. So water enters like this. So this is the steady state or steady state water table. This is your steady state water table. Now, what is your doubt?
Sir, H1, H2 are water table decrease, sir?
Yes, they will decrease. They will decrease because this well is far from the.
Sir, what does that drawdown curve indicate, sir?
Drawdown can indicate the level by which the water table drops. You see, when you are pumping water like this, okay, so water will be entering into the well. So the water table here will now gradually reduce.
Decrease.
And it will occupy this position.
Okay, sir. That one H1 is initial water level, H2.
No, H1 is not initial. It is at radial distance R1. Okay. And H2 is at a radial distance R2. These are the two observation wells. This is one well, this is one well. This is your pumping well. This is pumping well. These are observation wells where you observe the water table. So there are two observation wells. See?
Okay.
Sir, the drawdown test well not there.
Eh?
drawdown దగ్గర టెస్ట్ వెల్ దగ్గర drawdown ఎందుకు లేదు సార్?
Drawdown దగ్గర
టెస్ట్ వెల్ దగ్గర drawdown సార్.
see, I will repeat once again. See, this is your pumping well. Okay? And this is observation well 1, and this is observation well 2. There are 2 more wells. So, this is the initial water table. Equilibrium or static, what we can call it as static. That is when there is no pumping. Now, when you start pumping from both sides of this well, from this side as well as from this side, in this part only, the fluid water enters. Right? Is it clear up to this point?
Sir, 2RW indicates what, sir?
Which one?
2RW.
I'll tell. Okay. See, are you not seeing the figure? What it is representing there? Eh? What it is representing? This is a well, I told. And it is 2RW. What is R? What does R indicate?
Radius.
RW indicates radius of well.
Radius of well.
So 2RW indicates what?
Diameter.
Then why you asked that silly question?
Clarification.
What clarification? Okay. So now the first observation well is located at a distance of R1 from the pumping well. Second observation well is located at a distance of R2 from the pumping well. See, you can have this R2 not in the same direction. You can also have, I will show you. See, you can also have your pumping well on this side. It is not that both are on the same side. It doesn't matter whether it is this side or this side. It doesn't matter. Do you understand this point?
Yes, sir.
Now, so this is the equation. This is the equation. So we got T as this. Now the relation I have asked you to calculate K. So what is K? K is equal to T divided by B. That's all. So answer is K is equal to 63 by 40. 16.3 by so this is equal to, say, for simplicity, let us take it as 16.4. So this is 1.64 by 4. So this is 0.41. Okay? Meters per hour. Understand? Is it clear?
Yes, sir.
Yeah. Okay. Now you can do any problem of this type. Now I am going to ask you another question. Now I give you the radius of the well given RW is equal to, say, 20 centimeters. So, what is SW? This is SW. So, how do you proceed? How do you proceed? Same problem, same data. What you do is, you have already calculated the value of T. Now, what is in this equation, you replace R2 and H2 okay, not 1 minute. You replace not R2, you replace R1 by RW and H1 by HW. So in this, let us see what are the known things. H2 is known. H2 is known. H1, now H1 is HW. This is not known. Q, T, R2, R1, So, what is the unknown? HW. So, hence you will get HW. Now, when once you know HW, you can use this. Okay, first calculate HW, then I will ask you how do you calculate, how you arrive at SW. So all of you calculate HW. Come on, I'll give 10 minutes time for that.
Sir, 66.45, sir.
66.45
Meters.
meters. Okay, let us see someone. I will note your answer. 66.41. Your number?
13, sir.
Tanuja.
66.45.
Huh?
66.45, sir.
45.
Yes, sir.
Okay. Now think whether you can calculate SW within known data. Is it possible or not? Only one answer so far?
Sir, I got 84.43, sir.
84 point.
Sir, I got 66.461.
4, 3. Your number?
4, sir.
So this is Harika's result. And Tanuja is.
Sir?
Yeah, 1 minute, 1 minute, 1 minute. Let me note.
Okay.
66.45 Tanuja. Yes, one more answer I am getting.
66.461, sir.
66.46.
Yes, sir.
Your number?
Number 6, sir.
Number 6.
Sir, 84.43, sir.
84.43. Your number?
5, sir.
84.437.
Next. Any more answers?
Sir. 84.437.
Your number?
2.
2.
Sir, 84.43, sir.
Your number?
12, sir.
12.
Same, sir. 9 years.
Tanuja and Durga, you verify? Majority of them got 84.43.
సార్
Whether
మీరు
you...
ఆర్డబ్ల్యూ సెంటీమీటర్స్ లో కదా సార్
సెంటీమీటర్స్ ని మీటర్స్ లో కన్వర్ట్ చేసుకోవాలని
కన్వర్ట్ చేసేవాళ్ళు మీరు
మేము కన్వర్ట్ చేసేసాం సార్.
సార్ అక్కడ క్యాన్సిల్ అయిపోతుంది కదా సార్, చేసినా చేయకపోయినా అవుతుంది.
I think 66.45 is correct answer.
అన్ని మీటర్స్ లో ఇచ్చారు కదా సార్, అదొక్కటే సెంటీమీటర్స్.
Yes, exactly. Number 4, 5, 2, 4, 5, 12. Have you substituted R1 is equal to 20 or R1 is equal to 0.2? Come on, tell me. Number 2, 4, 5, 12.
అక్కడ R2 కన్వర్ట్ చేసిన R2/R1 ఉన్నప్పుడు క్యాన్సిల్ అయిపోతుంది కదా సార్.
R2/R1 వస్తుంది కరెక్టే, కానీ పైన మీటర్స్ లో ఉంది, కింద సెంటీమీటర్స్ లో ఉంటుంది.
చేంజ్ చేయడం మర్చిపోయాం సార్, సారీ సార్. 66.46 వస్తుంది సార్.
ఎవరు ఇప్పుడు హారిక చెప్తున్నావా నువ్వు?
ఎస్ సార్.
సో హారిక ఆన్సర్ ఆల్సో 66.45. ఓకే.
ఎస్ సార్.
So number 4, 6, 13. మిగిలిన వాళ్ళు ఎవరు ట్రై చేయలేదు. See how simple problem, how you have committed mistake. So this is how you will be unnecessarily losing your marks. Just forgetting conversion of centimeters into meters. Okay. Let us take one more problem.
Sir, how we will get SW, sir?
Is it possible now? You tell me.
No, sir. If you know H0, it is easy to find.
Yes, unless otherwise we know H0, we cannot get SW. So we cannot calculate SW. We can calculate only HW. Right?
Yes, sir.
Now, this is the question. You see, earlier I have asked you to calculate SW, right? But it is not possible. Now, this is the solution. This problem gives you the same thing. Now you look at the data. The diameter of the well is given. Well diameter is given as 1 meter. The discharge is given. And B is given. Right? Now H0 is also given. And 2 observational data is given. Now you are supposed to find head and drawdown. Right? Now you proceed with the problem. First you have to calculate T. So for that, now what we have done is written is we have written the same equation. See, this is the equation. This equation or this equation or whatever is this, all are same. So if you take this equation, so this is how it is written. T is equal to Q by 2 pi S1 minus S2 log R2 by R1. So this is our equation. This is the equation. This is the equation. So this is the same equation. So substitute this data. So for S1 minus S2, you write H2 minus H1. So what is H2 minus H1?
$1.3, sir.
So here what he has done is, in this, he has calculated S1 and S2. How he has calculated S1 and S2?
By using H naught, sir.
H1 minus H2, sir.
Yeah, S1 is equal to
Minus of
H naught. No. H naught minus H1. What is H naught? 40. So 40 minus what is H1? 38.2. So he got 1.8. Similarly, S2 he got you need not calculate here. You can directly use H2 minus H1 for S1 minus S2. Okay? So now you get T. Then the next step is what you had done earlier. Use this value of T and replace R1 and H1 by RW and HW. So calculate HW. Once you get HW, subtract that value of HW from H0. So you will get SW. Come on, complete this. Again, maximum 10 minutes. Have you completed? Again, let me write answers. First, we will write answers for HW. Because answer for SW is very simple when once you get HW.
Sir, H.
So you are given with Q. Sorry, you are given with T. H1 H2, R1 and R2. So find Q. T is 12 meters square per hour.
Sir, 81.6 meter cube per hour వచ్చింది సార్.
80
1.6.
Q.
Yes sir.
ఎప్పుడు కూడా ఆన్సర్ మీరు పొడి నంబర్స్ లో చెప్పకూడదు. యూ షుడ్ టెల్ ఆల్వేస్ విత్ యూనిట్స్.
Meter cube per hour.
ఎంత 80?
81.6 sir.
యువర్ నంబర్
13 sir.
Sir, 81.41 వచ్చింది.
ఓకే, దట్ డజంట్ మ్యాటర్. స్మాల్ డిఫరెన్స్. క్యాలిక్యులేషన్స్. యువర్ నంబర్
5 sir, 5.
Sir, 81.41 sir.
ఓకే, నంబర్
4 sir.
కానీ ఎందుకంత డిఫరెన్స్ వచ్చింది? రాకూడదే. బికాస్
Sir,
ఓన్లీ వన్ స్టెప్ క్యాలిక్యులేషన్. 641.
Sir, I got 81.46.
ఓకే, $81.41 or maybe correct.
Yes, sir. 81.
See, if your calculations involve more than 2 steps, and normally what you do is you round off, so then there will be problems, then there will be error. So I think Tanuja,
Sir,
how you have calculated? Have you simplified at any one stage and then substituted?
yes sir.
Perhaps you have calculated log R2 by R1 separately,
Yes sir.
and then that rounded and substituted in your
Up to
equation.
2 decimals I have taken sir.
Eh?
Up to 2 decimals I have taken sir.
మీరు ఎక్సెల్ షీట్ లో ప్రాక్టీస్ చేసుకున్నారు అనుకోండి, చాలా ఈజీ అయిపోతుంది. Okay, let me see the correct answer as per the one that is given here. $34.5 HW. మీకు ఎంత వచ్చిందన్నారు?
Same sir.
సేమ్ కదా?
Yes sir.
Suppose you use R1. Here he has used R2 and H2. Suppose you use R1 and H1. You should get the same value. Come on, verify. So here HW is equal to H2 plus that he has written. What you can write is H1 plus Q by 2 pi T RW by R1. Oh, I'm sorry. All right, ante ante. ఇదే కదా ఇచ్చింది మీకు ప్రాబ్లం. ఇదే సేమ్ క్యూ అదే కదా రైట్. So you should get this same value. Okay. Now you tell me what do you have next hour? You have class?